the atoms and molecules are the basic building blocks. The topic is also very much relevant in the present day developments that are happening worldwide. And students of this school and the students who are going to be benefited by this program should not really miss the kind of revolution that is happening in the world of nanotechnology. The concept of atoms and molecules emerged very much in the 6th century BC, sage Kanana, who expounded a philosophy which is called Vaisheshika philosophy, which is based on atomism. And we have the traditional interaction with Greeks in those days, and Democritus, who is considered as the father of concept of atom, who told that matter consists of indivisible particles called atoms. But most of you will read them as more as a history. But when it comes to the modern day chemistry, none of you would have missed the great contribution of John Dalton. His work has led to a scientific cataloging of the cumulative knowledge till that time, and brought forth the fact that it is the atoms which constitute matter. And he had also explained how the compounds are formed from the atoms. So, Dalton's atomic theory is something that is the basis on which all our physics and chemistry, especially chemistry, is based. Now, when you say atoms and molecules, it is not that man is satisfied with what he sees around. It is something much more. You always look for something which is the ultimate. Either the largest or the farthest or the biggest. So when you look at it, you look for what is happening, in the universe. You look at the sun, you look at the planets, you look at the stars, and now, you look at the galaxies. You have very powerful telescopes which can look farthest the galaxies. So this is something which man, due to the nature of enquiry, has always tried to understand. And we are not in depth of our ancient scientists, astronomers like Aryabhatta and Bhaskara. So they have all looked at the wonders of the cosmic universe. But there is another world, another extreme, where one tries to look at the smallest things. Like, for example, the biological species like bacteria and viruses. So, which are something that are accessible by ordinary optical microscope. You need to have a very powerful optical microscope to see, viruses and blood cells and all those things, which are now becoming more and more commonplace. So the quest for looking at biggest and smallest is always there. It is not that we are always driven by what we see with our eyes. But when you try to look at the atoms and molecules, it is very difficult if we rely on what is traditionally available, microscopes. So one tries to look for instruments which are capable of exploring the world of atoms and molecules. After Dalton's atomic theory, the structure of atom itself was not very clear. And the kind of developments that have taken place at later days, especially in the later 19th part of 19th century and the early part of 20th century has really driven the science, and which made an entirely paradigm shift in man's thinking about the way the microscopic world works, is responsible for so many things which we are enjoying. Now when we talk about atom, the structure of atom comes into the picture. You can say atom, this is the smallest indivisible particle which was thought about like that. It's not really true as of now. We know that the atoms are indivisible, but the kind of knowledge that existed at that time told that atoms are indivisible. But atoms are indivisible, but what is the structure of atom? What is it constituted of? So these are the things which people like Rutherford and Niels Bohr, they all want. Rutherford, I can tell you, is one of the greatest experimental scientists who single-handedly worked on the structure of atom, and whose laboratory consisted of very eminent students who studied under him, who themselves went on to get Nobel Prize later years. Rutherford himself is a Nobel laureate. But then his students, almost a dozen of his students got Nobel Prize. So that's the kind of experimental acumen he had, this Ernst Rutherford. I am just putting the stamps because this is something that really is the ultimate recognition that a country can give. And of course, the present day with emails and other things, many people do not know. I'm sure that in the next generation we have to ask what is the stamp. But this is something which really gets you a recognition. And I try to put these figures in stamp because I know the kind of audience which I am trying to reach out here. The Rutherford, with this very famous experiment, using a gold foil and impinging alpha rays, which are positively charged, he found that most of the alpha ray goes transparent, and some of them are deflected and some of them are recoiled. I am not going to go into greater detail because these are some of the things which you would have studied, but which showed the atom consists mostly void. But he could really point out the exact size of, more or less exact size of the nucleus which is positively charged. And he said it is more like a solar system with planets revolving. But he didn't put them into any definite position. But it was Niels Bohr, his most illustrious student, and also one of the greatest figures of 20th century revolution, quantum revolution, and who really was commanding and trying to bring together all kind of explosion which was happening in knowledge at that time. He was a kind of a leader who was looking at different works in different places. He thought about the structure of atom. He put all these electrons into orbit and said that these electrons of different atoms, starting from hydrogen, can exist only in definite orbits.